The title of my talk was Charge is on Your Side, and it's really about the use of charged materials, in particular charged polymeric materials, that can be used to modify the surfaces of nanomaterials for drug delivery and human health. Nanomaterials are particularly helpful to deliver drugs because they can actually enter the bloodstream and then, because they're small, accumulate in certain organs or tissues. We can also use these charged layers that we put on our nanoparticles to target the nanoparticle specifically to tumors in the body. And tumors can actually allow the accumulation of nanoparticles much more effectively. One of the challenges that we are looking at right now is the ability to deliver very large nucleic acids. It turns out that our material system is excellent at delivering short, silencing RNA. Now we're beginning to work with mRNA, which is larger, and we found new ways to complex them with proteins that help the mRNA get translated. But the next step will be to deliver even larger RNA and DNA, nucleic acids, so that we can deliver full genes and do it very effectively. And there's a real challenge there because we want to wrap up these negatively charged nucleic acids, but we also need for that package to be released at the right time in the cell. I hope that people gain from my talk the idea that you can use polymers to modify any range of surfaces, and that the electrostatic assembly process is very simple, it's water-based, but it can be used to wrap up even the smallest nanomaterials. On top of that, charged materials in general are very important in our range of materials that we can use for drug delivery. For example, we can take anything from a very small but highly positively charged molecule to a complex that has been generated and use polyelectrolytes to deliver a number of drugs from small molecules to RNA to proteins. I first got excited about chemical engineering when I was a junior in high school and was going to be a writer of children's books. But instead of becoming a fiction writer, I got excited about combining things in a chemistry lab and creating new materials out of systems that existed before. This got me so excited that my teacher told me about chemical engineering. I later went on to undergraduate, and as I was studying chemical engineering, I learned about polymer science, and I thought it was the most fascinating thing, that you can take extremely large molecules and design them to have different function, that they can do everything from make a material conduct electricity to wrap around a cell or deliver drugs. And over time, I began to look at materials in both of those areas. I found it very exciting.